think you're muted.
Thank you. Sorry, I don't know what happened there. My computer decided to, I don't know. It just wanted to shut down. It looks like I forgot to update my virus protection. I don't know what's going on in this computer. It's not happy though. All right, let's try this pentane shenanigans. So it doesn't matter what the hydrocarbon is. We're dealing with pentane, but it's always going to follow the same system. Your hydrocarbon combines with oxygen. And what does it produce? CO2 and H2O. Then you just want to balance. So balance carbons first, 5 here, I'm going to put 5 here. Then balance hydrogens, 12 here, so I'm going to put a 6 here to give me 12. That's a total of 16 oxygens. So I'm going to put an 8 here to balance that at 16. If we had instead done it for, methane, CH4, and I said, write the equation, you would do the same thing. You add it to oxygen, you produce CO2 and H2O, and then you just go through the process of balancing. Carbon's good, hydrogen, put 2 here, and put a 2 here, and then you're balanced, right? So the coefficients change, but the actual material is the same. It's still oxygen. I gotta pull up the slides again. Okay. So we're getting there, almost finished for today. So this is some different chemical reactions that you are responsible for. Precipitate reactions, being able to identify them, being able to do net ionic and complete ionic equations. Acid-base reactions, being able to identify those and come up with products, which are water and salt. Gas evolution reactions, it's just identifying. Oxidation reduction reactions, you really only need to know the definitions off of that one slide, so just know it conceptually. Combustion reactions, I want you to be able to write a combustion reaction, okay? So I could give you the hydrocarbon and you know that it needs to combine with oxygen to produce CO2 and H2O. So this is a way to describe different types of chemical reactions by like what the properties are. There's another way, and we can layer this on top of the other ones. So you could be a precipitate reaction over here and also be a double displacement reaction, okay? These types of reactions are being classified off of what the atoms do. So a synthesis or a combination reaction is a reaction where, we can go back to sort of our dating idea, this is where 2 people get together, okay? So A and B are alone and they come together to form a molecule. Decomposition is a breakup. So we had an AB compound relationship and they broke up into their individual elements. A single displacement, this is like the home wrecker situation. So B and C are together and A comes along and looks a little better and boots B. So we can see over here, C has now gravitated towards A and removed B. And then the double displacement, that's that swinger situation where partners swap. Okay, A goes to D on the second guy and C goes to B. We flip-flop. So some examples of these, this would be a great example of a synthesis reaction. Sodium combining with chlorine to produce sodium chloride. Two individual things coming together as a couple. Decomposition of water here. You can do it pretty easily with a battery. We've got water. We break it up into oxygen gas and hydrogen gas. Okay, decomposing. Single displacement, I've got a stick of zinc here, and I'm going to drop it into a solution of copper 2 chloride. Well, what ends up happening is the zinc is a better match for the chlorine than the copper is. So the zinc will come off of the stick and the copper gets sort of rejected and deposited on the stick. Double displacement, this flip-flop. All of our precipitate reactions, acid-base reactions, and gas evolution reactions are all examples of this double displacement. So chemical reactions can be synthesis, decomposition, single displacement, or double displacement. Let's look at that homework we did, or rather the problem that we did. We balanced them, and no, we don't want that. From that worksheet, and we will just sort of classify if they are synthesis, decomposition, so on and so on. So this first one here, even without it being balanced, we can look at this and say that is a synthesis reaction, right? Two things coming together. Number two, this is a decomposition. We had a full unit here and they've broken apart into the individual things. Even though the K and the Cl are together, they still have broken apart. So we would decompose that. This right here, number three, this is a single displacement. We had a couple, another one came in and they swapped places. Number four, this is a synthesis, two things coming together. Number five is a, this would be a double displacement. So the OH and the H come together for the water. This next one here, 6, this is also a double displacement. Okay, so you just want to be able to identify if they're single, double, so on and so on. And that is it for chapter 7. We're done with chapter 7. Thursday, we're going to be doing chapter 8, and then your test for chapter 8 is going to be, or sorry, chapter 6, 7, and 8 is going to be on Sunday. So quick turnaround because we're getting close to the end here. So let me know if you have any questions. General questions, just throw them out there. Otherwise, personal questions, you can stay around. And I will see you guys on Thursday. Have a nice day.
Thank you.
Bye.